Hi, and welcome back to FyneConf 2021. We do have 5 other great speakers, which I can't wait to welcome to the event today. But before I do, I'm going to do one additional segment about architecture and design. Hopefully this works as a refresher for people who know the project, or a chance to understand it more, and an introduction to anybody who's brand new to what we're doing here. Now, our design is split into the user interface and the API, but I thought I would start with the UI design. As you'll have seen earlier, and are probably quite familiar, this is loosely based on the material design language. It's a really great place to get started. They've worked so hard on a fantastic look, and their icons are really excellent. We embed them so that they're available for all of the Fyne applications. But we found its background can be a little prescriptive at times, having come from a web setup and then moving into Android. It didn't necessarily adapt well to the desktop. So we've made some tweaks here and there. You'll notice padding is slightly different font size as well. It's an opportunity to work consistently across these devices and yet not look particularly out of place. In fact, if you're on Android or on Windows 10, it might even look quite natural. We have used vector graphics throughout. If that doesn't mean much to you, don't worry. It just means that we're not placing pixels in the way that these widgets are designed. It's going to scale really, really well, whether you've got a low resolution screen that's far away or a very high resolution screen right up close. The applications are going to adapt and look crisp. It delivers a light and dark version of the default theme, and we encourage people who are writing their own widgets or their own themes that they do the same, because applications are going to adapt appropriately, and it's best for the users if it matches what their expectations are. We provide a lot of standard widgets, and these conform to certain layout and theme definitions that are documented through both material design and our own documentation as well. It gives a really consistent user experience. It may not be exactly how other applications look on their system, but it will feel familiar and really easy to understand. And simplicity is really key. We know how important it is that it's easy to build an application, but it should be equally easy to use the applications that have been built as well. At the core of this, of course, is to be a platform agnostic toolkit. And what does that mean? Well, in case I didn't say it earlier, this is writing your application once and expecting it to run everywhere. Here, your first Hello Fyne application launches in the font size you would expect in the theme that matches your desktop. When you run it on a different type of device, it's going to adjust the scale. Here, a side-by-side comparison doesn't seem identical, but when you're holding your phone, that font size is equivalent, so it's making this adaptation for you. For each platform that the application can run on, the drivers, which we'll look into in a moment, are going to handle the different behaviors for multiple windows, how notifications are sent, and how the application process for installing is going to work as well. We do our best to make sure that the default theme and font size and preferred color are going to match the user preference. But if you wish, as an end user, you can override these settings. You can specify a bigger or smaller scale, like you can see there, or you can specify the dark variant of the theme if you think it matches the application better, or if your operating system default isn't being picked up for some reason. And all of these things can be configured by the toolkit settings application, which is also available in the Fyne repository. And if you run Fyne settings, it looks like this. You could see that the normal font size is default and the blue color is, and the theme is going to pick system default. But if you prefer, you can override any of these for your particular preference or setup. And the way that this is built means that although the custom themes are there, although the standard themes are built in, applications can deliver custom themes. And these are just going to work with the standard widgets and also with any custom widgets that are correctly using the theme API. So here you can see a BBC Micro emulator that I built on top of somebody's Go library for parsing basic programs. That was a lot of fun. And what you see is really just a label with multiple lines of text and a background, but it's all updated to the theme that's built into the application. And if you want to explore what theme capabilities could be, or if your application is looking for a brand identity or a different style, you could try out something like this theme generator that's been built by Kiyosuke Fujimoto at the URL found below. And that's a great opportunity to see how things vary in the standard widgets. And it's a live updating interface based on the current selections. And then you can save your current state into a Go file that it can be then packaged into your application. So that's the user interface design, but the API design is just as important. And so we've thought long and hard about how this should be done. Firstly, we have implemented basically everything here from scratch with the help of some really great libraries like GLFW for one. But we've taken this opportunity to start from scratch. We've removed all of the legacy constraints that graphical app developers might be familiar with, working with a main thread, communicating across them, managing the memory of your widgets and the life cycle of the graphical elements. That's all gone, and so we're able to start with something much simpler. The code is focused on behavior, not on render details. And this is a big difference and quite a step for people who are more familiar with developing web applications, for example. We're not really an API that says I'd like to move it a bit further to the right or a slightly different shade of foreground color. It's more about what's the user going to do. I want an entry widget and I'd like to set this text to be selected, that kind of thing. We're also very careful about the naming of everything in the API. It has to be really obvious. A consistent API that's minimal is going to be so easy to learn for a new developer. And we don't want it to get much more complicated, because although the developers of the project might be learning and building up on top of all of this, somebody coming to the project new doesn't have any of this built-in knowledge, especially because we've changed some things about how graphical APIs might be delivered. So we're trying to get a path of least surprise for developers. It should be clear when writing code, obviously what things are going to do. And with a little prod from a good IDE, it should be possible for all of this to be quite clearly written with a little autocomplete here and there. Also, separation of concerns is a big element of maintainable software, and the Fyne toolkit is certainly growing, and I hope a lot of applications that build with it will too. By keeping things modular, we can enhance the reusability and make things easier to test as well. If your application is broken into components, everything is a little bit easier. If you'd like to learn more about this design process, there's a blog post on Changelog's website based on a Go Time episode, number 116, where we talked about Fyne in its early stages and how we approached the design of the APIs. And we've really tried to stick to that. Now we should look at how this looks on screen. I've called this canvas architecture. It's about how it's created and presented to the user. The approach that we've taken is a stateful API. Now, this doesn't have to mean much, but if you've heard of immediate mode, it's basically the opposite. We store state for widgets, and we only refresh if that state has changed or if the developer requests it. At the top of every window is a canvas. That's the base of our abstraction. The window itself is part of a driver, and we don't need to worry about it. We control what's inside. Every window will contain many canvas objects, which are the primitives that can be drawn, and it probably has a container. because that manages multiple different canvas objects and helps to lay them out. We'll hear more about canvas and layout. We'll hear more about containers and layouts from Jacob later on. A widget, which you can sort of see at the top right of this illustration, is where we add interaction. Basic canvas objects are just drawing. But at a widget level, we can start interacting to tap, drag, and all sorts of other events as well. Users can also extend widgets. So if you would like to add some functionality to an existing widget, then extending it is probably the best way to do it. You can even intercept certain events and modify it. We find this to be really helpful. If somebody wants an entry to contain only specific letters or numbers, then it's possible to intercept the typed rune and block certain calls from passing through if they don't match the expectation. And then lastly of all, you could create custom widgets. They don't have to be based on any standard widget, and also they don't have to conform to the theme. If you have specific reasons to draw something completely different, you can. But a custom widget is going to be just as well contained as any standard widget, and it can be shared around. All of these widgets are basically just a container, but it contains a minimum size and a layout as well, all wrapped in a widget renderer. More information about that is available on the website as well, if you would like to get into building custom widgets. It's not as difficult as it might sound, and in 2.1 we added a new simple renderer, which means that you can actually pass it a canvas object or a container that will be used to render your widget, and then you can just control updating its state in a refresh call. Pretty straightforward. But how do these things get drawn to screen? So we have a graphics abstraction in the architecture as well. The drawing of everything is handled by drivers that we've created. And although you might think it would be better for widgets to describe how they're drawn, or in fact for your canvas object, your line, to say here's how you draw a line, that means that we can't optimize it. And so instead they pass information about what they should be, how they should be looking, the properties that they have into the driver, and it can do the rendering optimally in whatever way meets the platform's requirements. So there the primitive draw objects pass the item information into the abstraction. A rendered item can then be cached internally until it's asked to refresh. So if you've got one item on screen of thousands of items, there's only one thing that really needs to change there, and the graphics card's just going to keep reference to the previous state for all of the other objects. Like I mentioned earlier, a widget creates a widget renderer, and that's going to manage a list of other primitive objects if it's drawing to screen. It's also here where you might want to be careful to use the theme API if you're applying certain colors. Or, in fact, you could avoid needing to manage primitive objects in their state by reusing other widgets, because one widget could use many other widgets inside its renderer. So you could choose to use a label instead of a canvas text if you would like to inherit the default theme in all its glory. If you wish to save what has been rendered to screen, you can use canvas.capture. That might not seem hugely useful for many applications, but if you're building an image editor, it might be really helpful. But also, if you're unit testing, then you can save what's going on to a file and compare it to a golden image if you want to make sure that your rendering is correct. And all of this might sound complicated, but at the bottom line, you don't need to worry about any of it. It's an abstraction for a reason. It's all hidden away. When you call app.new, it is detecting the details of your runtime environment, and it's going to update according to the graphics technologies available, the devices detected, and so forth. I mentioned drivers a couple of times. Let me just go into the details then about which drivers we have implemented. And if you're not interested in how Fyne works internally, you can probably skip this slide. So we have the glfw driver, which is built on top of a C library, but it's all bundled in, so it's not a dependency for your users. This handles the desktop applications. It will be used on Windows, macOS, Linux, and BSD. That's going to handle input, output, and creating windows on screen, and various other things like showing notifications. There's a mobile driver. That probably has a more obvious name, and this is going to be used for phone and tablet devices such as iOS and Android, and others still to come. But more surprisingly perhaps is that there's a test driver as well. And this is an in-memory driver that's going to be useful for your unit testing. This means that we can run our full applications in test mode without needing to show them to screen, without needing to take hold of the keyboard and mouse to generate taps and clicks and check that your application is doing the right thing. So that itself is also really powerful. And backing these drivers, we have some common code that are called painters, and this is what actually draws your canvas into a window. The standard one used in most drivers is GL. This is using the OpenGL hardware acceleration to render, and on embedded devices and others like Apple's M1, this is going to pick up OpenGL ES instead, which is the embedded systems version. Essentially it's the same technology but with a slightly different language for describing how it works behind the scenes. And then we have a software painter. This is really mainly used for the test driver. It has a couple of helpful pieces of functionality though. So if you wish to render a single widget without loading an application to see how it runs, you can use the software driver directly and render that widget into an image file. So that's a lot about the detailed stuff. Let's look again for something a little bit more developer level. The main packages that are part of the Fyne project. So these are all under fyne.io/fyne/v2 namespace. The one that I've mentioned a few times already, the main entry point, is app. This is where you call app.new, and it's going to do all of the auto detection and setup of your application when it's run on the host computer. I mentioned Canvas in passing. This is the package that defines the draw elements that are supported by each of our drivers. So line, text, gradient, image. There's plenty of others in there and you can see what's available. These are the only types of graphical elements that can be drawn by the drivers. You can't pass in your own because the driver just won't recognize it. And this may seem a little bit of a drawback, but it means that we can optimize, like I said, for the graphics pipeline on the device. If you want to draw something very specific, then you can use the raster canvas type, which does allow you to pass pixel data through. We have the container package and also a layout package that governs container layout. This is for grouping elements visually, logically, on moving them around on screen, and I'll let Jacob talk about that later. We have data binding, which I mentioned before, and data validation. These are places that are going to really help with the data flow in your application and to set up more complicated two-way connections that may be based on certain validation criteria. I mentioned before a file dialog and a color picker. All of our dialogs are in the dialog package. You can find things for presenting standard user information. They've got errors, confirmations, and for gathering input like a form dialog or a file dialog. The storage package we'll hear a lot more about later in Charles' presentation. That's our file and data abstraction when you're looking for information from outside sources. The test package I've also mentioned, as well as rendering an application in memory for unit testing. There's a lot of helpful tools in there that you can use. Theme provides the standard theme implementation, and you can use that to learn about the theme that's loaded. And widget is our standard pack of widgets. If that's not enough, then you can also check out the FyneX package, which is a community repository of additional widgets. Before we finish up this segment, let me just show a little bit of code for people who are really excited but haven't started their project yet. Since Go 1.16 we need modules, so we start by creating a project folder. We go into the folder, we initialize our module, we'll call it project, and we use go-get to say that it will be using the Fyne package. This is our hello world code. It's pretty straightforward. We just import the app and widget packages, and much like the markdown illustration in the previous presentation, we just create a new application and a new window inside that application, and in this case we set the content to be a new label widget that just says hello Fyne, and we say show and run, a helpful shortcut for show the window and run my application. To execute this code, we edit the file, perhaps called ui.go with Vim or another editor, and we just say go run like any other application. And you might not be surprised to see hello Fyne appear on your screen. But also, we might want to write some tests. I mentioned before, test-driven development is a big part of how we're trying to make code more approachable and more reliable, even maintainable going forward. So here we have some other code. There's a few more imports here. We're importing the standard testing library and also Testify, which I find useful for writing unit tests. And we've imported the Fyne test package. Here, this is going to run a test in the normal way. We create a new entry and we use the test package to simulate typing hello, and then we assert that the contents of that entry is hello. Not much of a surprise there. But then we double tap on the entry, again using a helper in the test package. We then verify that the selected test text is hello, which it is, and also that the cursor column has moved to column 5. We run this test, much like any other test. We say go test, and this is going to be using the standard tools. There's nothing even to see when this works. When this runs. It's just going to run the test and exit, nothing on screen, just a confirmation to your console, which means it's going to work well in your continuous integration environments and so forth. So that's an app built and run. How do we get it to people? So there's a helpful Fyne command for packaging. You might recognize the URL. It's alongside Fyne demo in our repo. We recommend on a regular basis using go-get-u to update the Fyne package. Each major release of Fyne, you might find there's functionality in there that you need to get the latest app bundles working for your app. And then we can just say Fyne package for our project. That's going to take the binary and build the metadata around it so it looks like a native application. That's by default going to work for your current operating system. If I wanted to build a Linux app and I was on a Mac, I could specify the operating system as Linux and it would build the appropriate bundle there. That will require some toolchain installation. You may have already and you might not. If that's a little bit complicated, you can use FyneCross, which is a great project that means that you don't need to manage the developer tools. It uses Docker images to provide those tools for you. We can also install Fyne applications. If you use Fyne install, it's going to install the application with all of its metadata into your operating system in a way that you would expect for a native application. Here you can see we've installed Fyne settings and it becomes available in our standard app search. You could also install it onto your Android device using OS Android. And just for completeness, you could do the same for iOS. Here you can see one of my home screen folders with a selection of Fyne applications that I have installed.